Keith Rucker at VintageMachinery.org. Back on the LeBlanc lathe today. We're going to be working on trying to get this machine properly set up and things dialed in. So in my last video, we made our first cuts, and if you watched that video, you'll remember that right out of the box, without any setup, when we did a little turn here of about, I don't know, that's probably about 8 inches or so, we had a couple thousandths of taper along the length of this, this piece, and that's not unusual. We did spend a little bit of time several weeks ago trying to kind of roughly get this lathe leveled up and set up, but hadn't gone back since that time and fine-tune anything. So the important thing on a lathe, when you're getting a new lathe or setting up a lathe or you know, whatever, even a brand spanking new lathe out of the box, direct from the factory, everything's perfect on the machine. If you don't take the time to get the bed, I'm going to call it level. Actually, it's not truly has to be level. It just needs to have no twist in the bed. But if you have any twist in that bed, you can have issues. And if you have an older machine, such as this one that has wear, you can also have issues from the wear. So what we're going to do here is a couple things. First thing I'm going to do is we're going to come back in here and we're going to double check the bed to see how level it is. And I'm going to use a little bit different method this time, using something that I learned from Richard King's machine rebuilding class. A little bit different way of doing it. But again, the important thing is that your ways in your bed, it doesn't have any twists. So you don't want it, the ways to be kind of, as your saddle moves across, it does a twist. And I'm exaggerating that. It can be just a couple of thousandths of an inch. But when that happens, it changes the geometry of where this tool enters into the part. And that can actually cause it to turn a taper, as in the case of what I saw right out of the box here. So first step, let's get a level over here. And let's see where we're at. So we're set up here now to make our first initial reading here and kind of see where we're at, see where this machine is, you know, right now. And I just want to comment, this process is often called leveling a lathe. And it's called that because you use a level to do it. But it's, again, not absolutely necessary that the machine be level in every direction. What is important is that wherever zero is here, when you move your carriage out, is zero out here too. Another thing is when people normally are setting up a lathe, and this is kind of out of the box how you would normally do things, is you would actually measure across the ways. I'm cheating a little bit here because I know I've got a machine that has wear in it. And so instead of measuring across the ways, I'm actually going to skip my level set up where it's reading level on the carriage, and we're going to move the carriage down the lathe because that's going to give us a more realistic indication as to what the carriage is doing as it moves along the way. So if you are familiar with machine alignment, you know about Richard King's class that we took. He actually has a tool called the Kingway alignment tool that you can run across here with indicators and actually with levels. And actually you can calculate this or look and see how the ways are. Basically what we're doing here is we're using the carriage of the lathe as a Kingway alignment tool. And again, this is something that Richard King taught us in his class as a way that we can do this. So I've got a level on here, and you know, one thing that I'll just point out right quick is that, again, I don't care if it's truly level. If you look down here, I've got a little tapered wedge up underneath this end. And what I did is I just made the level read level because I need a place to start. Now, I've got a stair at 98 on here right now. This level is accurate to 5 thousandths per foot. So, you know, this is an 18-inch level. So over this, you know, it's about 5 thousandths. But as I move the carriage down, for every foot that I move it down, for every line that it reads, that's showing 5 thousandths change in how level or how coplanar, I guess, my ways are. And I'm going to use this for setting it. I actually have a more accurate level that's accurate to a 0.5 thousandths per foot. But right now, because it's such a fine measurement, if this is out very much, that lathe will quickly get off a bubble. So I'm going to start with this bubble or this level, and then we'll probably move to the other level as we get things dialed in a little bit. So right now I'm looking on here and I got it zeroed out, so the edges of my bubble are on the two long lines there. In the camera, it probably doesn't look that way because you're not looking straight down on it. And what I'm going to do now is we're just going to roll the carriage down. I'm going to just roll it the length. Well, let's just stop right there because that's kind of the area of movement. And looking on here, the bubble has hardly changed at all. So that tells me, you know, in this range that we just moved it, it's pretty level. And again, this is where most of the wear in the lathe is. As we move out toward the other end, and let me move my camera so you can see this. So as we move out toward this end of the lathe, this is the end of the lathe that doesn't see a lot of use. And I can actually feel my carriage getting tighter as it comes down here because there's not as much wear in it. And I'm going to look and see now, and now I'm off about a line, so about 5 thousandths. You know, over that, probably about a foot, it's moved one bubble. So now, once I get out here in the area that's not, that isn't worn, it moved about 5 thousandths of an inch out of alignment. So that's just something that I need to keep in mind. But again, most of my turning is up here closer to the end. Probably when I get out this far, I'm going to be turning between centers, and there's some other tricks we can do to deal with that. I'm going to bring it back down, and let's see where we are when we come back all the way. See if it goes back to 0. And it does. So what I'm going to do now is I'm going to go grab my other level, my Master Precision level, that's more accurate, and we're going to repeat this at least in that area that sees the most use. Okay, I've got things set up now with my other level. This again is a Starrett, but if you look here, it says 1 division is a 1/2 thousandth or 5/10 thousandths of an inch per foot of level. So again, as we move this down, for every line that we go is a 1/2 thousandth, or before it was 5 thousandths of an inch per line. So I'll start out looking, this level is so ticky that just barely moving this wedge will change this bubble a lot. So I've kind of played around with it. And right now on this line down here, you got the big bubble, which is 0. It's about halfway between to the next line. So, you know, that is my starting point. And I don't know how well you can see that in the screen, but we're going to go ahead and move it down and see how far it moves. All right, we'll start here. I'm going to come to about right here. I mean, again, that's the limit of where most of my travel will be, and you have to give this a second to kind of settle in. And right there, it's pretty darn level. The bubble is about in the exact same place it was before. I mean, it may be off by a tiny fraction of a bubble, but it hasn't moved an entire line yet. So now I can actually feel the lathe getting a little bit tighter right here. So this is getting into area that's not worn as bad. And I'm going to go ahead and crank it on down farther. And you can start to really see that bubble moving now. So now it's actually moved completely off. And before we were saying 5 thousandths. So, you know, that's beyond what this level is actually capable of reading. So, you know, this is a really good indication. I just go back that far. Okay, I'm going to go back a little bit more, and you can really see that bubble starting to go back down. So I've got, actually it's back to where it was a minute ago. So, you know, this is, you know, mapping this thing out tells me, again, for the first, you know, 2 foot off my chuck, 18 inches 2 foot, I'm probably fine. When I go out beyond that, I may start running into some taper issues. So what I'm going to do now is we're going to make some test cuts on the machine and actually look at the measurements of the diameter and see what the taper is. So the piece of metal that I got in here is just a piece of mystery metal that I picked up out of the museum. This actually was one of the old journals that ran the side heads on the Vance planer matcher. And these were milled out down here because this was where Babbitt was poured around it, and that was basically a thrust to keep the shaft from sliding up and down in the Babbitt. But ironically, this is kind of what we're after with making this test piece. What we want to do is we actually want to come in here and leave an area down here on the end. I'm just going to leave this boss here, but I'm going to turn it down and just leave another little boss kind of up here where I basically am only turning here and here, and I'm not turning all the way in between. Once we do that, we'll take a light cut on this end, same setting, a light cut here, come in here with a micrometer. Instead of turning the whole distance, you can actually get wear from your cutter or whatever that can make some slight differences. For really fine adjustment, we want to actually take all those equations out. So let me go ahead, I've just got a cutter in here. I'm going to just turn this into a test bar. I tell you what, I think I'm just going to turn that out just to really simplify this, and we'll show you how to do this process. All right, we're over here now, and what I want to do is just take a real light pass off of each one of these ends here, and let's see where we're at. So I really want to take a real light cut, so I'm just going to feed it in about 1/1000 of an inch past where we were at. I've slowed my feed down to get back down to a real fine feed to get a real nice finish here. We're going to let that work its way across. Go down to the other side and do the same thing here. I'm only taking about 1/1000th or 2 on this pass. Come in here now, get a real good reading on my micrometer. I'm on 24 and about 1/10. And I'm on 20 and about 3/10. Basically, I'm about 4/1000ths larger on this side, this end, than I am on this end. Is that right? Yeah, so we're at basically 24 there and 20 there. So about 4/1000ths larger on this end. So let's stop here for a minute now and think about what we want to do. So I'm about 4/1000ths larger down here than I am on this end. So what I really want to do is I want to introduce some twist into the bed to kind of correct for that. And I want to make this cutter, the farther out you go this way, I want it to actually come in farther. So what I need to do is I need to raise this side of the bed up or drop the back side down. I'm going to just work on the front side here, so I'm going to go down below, I'm going to get my wrench, and I'm just going to tighten up my set screw down here. I don't know, I'm going to probably do, that was about 1/8 of a turn, and we're going to come in here and we'll repeat this test and see if it made any difference. So let me fire up the lathe now, and we're going to just make a light cut on both sides again and get some measurements. Be back in a minute. All right, so we made that 1/4 turn, or 1/8 of a turn roughly, movement down there on that one leveling screw. And I come in here and we took another light cut off of both sides, and I'm gonna come in here and let's see where we're at now. All right, so I am at about 18 and 2/10. I'm just looking at the last couple of numbers there. I'm not reading the whole measurement, because we're going to be within a couple thousandths here. And looks like I'm about 16 and 9/10, so almost 17. So that's what, 1.3 thousandths. So just that little bit of an adjustment on that leveling screw we were able to make a fairly significant amount here. We took a little over half of that run out. So I think what we'll do now is come out here, we're gonna make another real quick, very fine adjustment to that one set screw. This time I'm gonna probably only turn it not an eighth, but probably a 16th of a turn. And we'll come back in here and repeat our test. All right, I've made about 2 more slight adjustments off camera. Probably between a 16th and 8th of a turn per. And let's get a good measurement here. So I'm reading 0.4. And I am reading just under 0. That's what, 10,000th under 0, so 24 9/10. So I've got this down to a 1/2 thousandth. So we got a 1/2 thousandth taper from here to here. Now I could probably continue piddling around with this, but guys, for the work that I'm doing, a 1/2 thousandth of an inch over, what was that, 7 or 8 inches? I can live with that. I can live with that, particularly on an old lathe. So I'm happy. So there you go, guys. Fairly simple process here, and something that you need to do on every lathe at some point in time. And guys, lathes will move around over time. Things will settle, the floor will settle. So this is something you just have to do periodically to your machines to keep them in trim. And again, I'm not so worried about is the bed level. What I'm worried about is how does it cut. This is the important thing. When we started, what was I, 4 or 5 thousandths taper? I've got it down to a 1/2 thousandths taper by just turning a set screw down here, not even one complete turn. Next thing we want to check alignment on is the tailstock in relationship to the headstock. And you really want to have this lined up both going in and out as well as up and down. Now the in and out is fairly easy to adjust. You've got a little adjuster over here that you can, this whole tailstock is designed to slide left to right for alignment. And also if you want to purposely turn a taper, you can actually, between centers, you can actually purposely rotate it out to get the taper that you want. So that function is built into the whole equation here. Now the height is a different story because when the machine was made new, it would have been set up pretty much dead on where this was exactly in line. But over years, these machines will wear, and what will end up happening is your tailstock will start dropping down in height as the bottom wears on this. So we're going to check both. We'll adjust it left to right. If we have to raise it up, this is a 2-piece casting, so you can't actually put shims in here. In fact, when I took this apart, there were actually some pretty good size shims in here. And quite honestly, I think they're probably too big. But I put them back in there. I'm just going off of, whoever was working with this lathe before. Hopefully they knew what they were doing, but we may have to pull those shims out. In fact, I suspect we will, and perhaps even shim it up with some different material. Now to do the alignment, I'm just gonna do a very easy test here. What we're gonna do is I've measured this. This is 2 5/8 in diameter, 2.625. And we're just going to basically turn down in the exact same diameter here. I'm going to be very careful on my dimensions, get it down exactly to 2.625. And then we'll just butt them up and use a test indicator to go across the front and the top to see how far out of alignment it is. And then from that we can dial it in. So I'm going to go ahead now. We'll turn this down to 2.625, 2 5/8. And then we'll go ahead and do our test to see how much adjustment we need to do. So I'm just going to turn this down. We don't need to go down very far. I just need enough area to mic on, so it's not a critical measurement. I'll probably just come in here and pick an area and go with it. Let's see, I need to... There we go. Plenty right there. All right, we're getting down close to our measurement here, so I'm gonna come in here with my micrometer. It needs to be right on the money at 625 to match the tailstock spindle. So we're about 14.5 thousandths over 1625 or 625. So I'm not used to this lathe, so I'm going to really sneak up on it because I'm trying to get used to my numbers on here. I'm going to try to take about a 10 thousandths cut here, or excuse me, a 5 thousandths cut, 10 thousandths total. And like I said, we're just going to sneak up on it because I'm getting used to how this machine works, getting used to the dials, etc. So we're about 8 thousandths over. So let me dial in a little bit more here. I'm taking about a 2 thousandths cut, 4 thousandths total. Again, I'm trying to sneak up on it because I just don't trust myself on this lathe yet to just dial in and go. I'm getting used to how it cuts, how it works, etc. I'm 3 thousandths to go, 3 thousandths over. So I'm going to take another light cut here. All right, we are pretty darn close here, so let's see, I'm gonna look on my tenth scale. I'm about 3/10 under 625, which that's gonna be plenty close enough to work with here. I don't know if you guys probably can't see that, but anyway. So let me get my indicator now and we'll get set up to measure the tailstock. So what I've done now is I've brought my tailstock up. I've butted it up against this diameter that we turned. I've got my tailstock is locked down. You want to make sure you get it locked down so you take any play out of it at all. Make sure it's down tight because that's how you'd be using it. And what I've done is I've zeroed my indicator on my test piece that I cut. And what I'm going to do now is I'm going to roll back. And again, remember, we haven't done any adjusting this. This is just you know, using the little scale back here on the back. There is a little scale on the back that kind of shows you roughly where it's at, but it's not a precision measurement. And we're going to roll over here to the tailstock, and it's off about 31 thousandths. So now with the indicator, what I need to do is just move the tailstock over and get it to where it reads 0. So let me get some wrenches and we'll start cranking on that. So there's 2 screws. I'm going to loosen this one up, and I think, and I always get this backwards, but okay, yeah, so I tighten that one up, and that one's going to push it towards me. I'll come in here until it reads 0, and then I'll tighten this one back up, and that should snug it in place. And there you go. Now, just to verify, 0, 0. So left to right, we have it lined up, and it should be the same on the back side. So now let me move my indicator. We'll get a measurement on the top and see where we're at. We got our indicator set up on the top now, and I did kind of roll it back and forth to find top dead center. We got it zeroed out, and I'm just going to roll it back now to the back one, and it's about a little over 9 thousandths, about 9.5 thousandths it looks like on the dial. That's not a 1/2 thousandth indicator, but it's pretty much right in between the 9 and the 10. So there you go. We're about 9.5 thousandths high on the tailstock here. And I want to just give credit where credit's due. Richard King taught us this method of checking your tailstock in our machine rebuilding class that we took a while back. And it's a really good method. I've never seen this method before. Some of you guys probably have. I've often done it with looking at trying to line up the dead centers between the two and kind of doing it by eye. And there's some other tricks I've done, but this is by far the best method I've seen yet. As far as it being high, though, I'm not going to take care of it right now because I'm going to have to get some shim stock. And like I said before, this tailstock down here is in two pieces. And when I took it apart and put it back together, there were actually some shims up underneath here. And they were fairly thick shims from what I remember, a lot more than 10 thousandths. What I'm going to need to do is pull this apart, pull those shims out, measure them, and then get some new shim stock. And I don't have that in hand right now, so that'll probably be done off camera later on, but I want to just kind of tell you what the process here is, put it back together, check it again. Now, one thing Richard taught us in his class is that you actually want your tailstock to be just a little bit high, you know, and when I say a little bit, I'm talking 1 to 2 thousandths high. You don't want it to be set to exactly 0. The reason being, according to Richard, and I agree with this, is that over time, your tailstock is going to continue to wear and continue to drop down. And if you have it within a couple of thousandths of being in height, quite honestly, it's good enough. So it's just good enough. Just trust me there. So the idea here is if you start out a little bit on the high side, as this machine wears, it will actually wear down to being dead on, and it'll take a lot longer for it to wear down to where it gets too low to where it's causing you trouble again. So even though we got about 9.5 thousandths to go here, I'm going to probably try to shim it 7/8 thousandths lower just to kind of get it where it needs to be. And again, I'm going to do that off camera, but you see the process. So there you go, guys. That'll be pretty much a wrap on setting this machine up, getting it, taking or adding or taking out whatever you want to, adjusting the twist in the bed to get your machine where it's turning, where it's not turning a taper. Get as much of it as you can. We got this down to about 1/2 thousandths over 8 inches. Quite honestly, my plan is I'm going to let this thing settle in for a little while, and probably before I start my first project, I'm going to come in here and check it again, because anytime you twist that bed, you know, it may not completely twist out. It's probably going to do some more settling, so it may need some more fine tuning, and I may even try to at a later date even get it a little bit closer than 1/2 thousandths. But again, we're just I made some pretty drastic changes to the machine, relatively speaking. Not really, you know, really we only twisted it a couple thousandths of an inch, but I want to let it settle, and we'll come back and check it again before I really start on my next big project, or first big project on the machine. Then we also got our tailstock set, as you see, and again, I got a little bit of homework to do on that, but it's pretty close. In fact, it's probably usable like it is. In fact, I know it's usable like it is, but we will go ahead and get the proper shim stock in there and get that taken care of as well. I can tell you a little bit, you know, I've had a chance now just messing around with this to actually do a little bit of work on the machine. As I mentioned in my video, I'm getting to know this machine. Anytime you begin working on a lathe or a mill or whatever that you're not used to working on, there's an adjustment period. There's learning that machine. And you know, the Lodge and Shipley out at the museum, I can turn excellent parts on it because I've been using it for a really long time, and I just kind of know the tricks, because you know, I know when you adjust the dial how much it's really going to cut versus how much it reads it's going to cut, and it's pretty close. But there's just little things like that you learn. And I'm getting to know this machine. I can tell you that it has been a little bit frustrating for me. Not because it's not a good machine. I think from what I've seen so far, I'm very happy with it. But man, everything on this lathe, it seems like, is backwards from the way it is on the Lodge and Shipley. And I'm just used to that machine. It doesn't mean that this machine's wrong and the Lodge and Shipley's correct. It's just what I'm used to. For example, the handle here to turn it on and off is over here. On the Lodge and Shipley, it's on this side of the carriage. So every time I get ready to shut it off, I reach over here and then realize, nope, it's over here. And then on the Lodge and Shipley, to make it, I think, go forward, you pull the handle up. On this one, you push it down. So it's backwards. Even down here on the tailstock, on the Lodge and Shipley, you turn it counterclockwise and it's actually feeding, or clockwise and it's feeding, and the handle turns backwards. So there's just there's a bunch of little stuff like that. The handle down here to engage the feed. On the Lodge and Shipley, there's two handles, one for the feeding this way and one for feeding this way. On this one, it's the same handle, and if you go too far, you actually engage the feed in the other direction. It's not a problem, it's just different, and I'm having some learning time that I'm going to have to spend getting to know this machine, but we'll get there. So far, what I've seen with it, though, I think this is going to be a really nice machine to use in the shop. So with that, we'll wrap this video up. Thank you guys for watching. Here's some things you can go home and check on your machine. Thanks for watching, guys. We'll talk to you later.